Hey Hopkins, what's up? Zach Pina here, and we're learning math.
Alright, so Kate got her shout out. Awesome. Okay, so what we just did was we reminded ourselves about switching from exponential to log form, and now let's go back. So this is 3 to the 4th equals 81. This is x to the 3rd equals 216. Now we know the answer is 6, but it just asks us to switch forms, so we'll leave it there. 8 to the negative 3rd equals 1 over 512. And this is natural log, so what's my base? E. This is e to the x equals 52. So, we've already studied exponents, we've already studied logs, and we know that logs undo exponents. So when we think about them in terms of a function, they would be inverses. Okay, so we talked about inverse operations before that undoes. These are inverse functions. And the images of their graphs, when we do inverse functions, are symmetric over the line y equals x. Because remember with inverses, we switch the x and y. And because we switch the x and y, they would be symmetric over this line. And so if we had a little coordinate plane, the line y equals x is that 45-degree angle one right here. So whenever we graph inverses, it's like we reflected it right over that line. Okay, so, whoa, here's all the answers. Let's try it from scratch. So we're going to figure out what the inverse of these exponential functions are. So remember to find inverses of equations. The first thing we did was we switched the x and y. So we'll do that first. If I have y equals 2 to the x, I have to think of this as x equals 2 to the y. So we switch the x and y, and we solve for y. That was our steps for finding an inverse. Step 1 was switch the x and y. And step 2 was solve for y. Well, now that we switched them, y is the exponent. And what do you have to use to solve for an exponent? A log. So this becomes log, what is my base? 2 of the answer part, x, equals the exponent. And because I'm doing an inverse, I could even do y to the negative 1 to denote that that's the inverse of the original function. So the inverse of an exponential function is a log function. All right, so let's do this one together. We switch the x and y, and we solve for y. All right, once again, y is that exponent. So, to solve for that, we have to use a log. This becomes log, my base is 3, and my answer part is x. And it equals the exponent. Okay, you try. Number 3.
You try.
Yeah.
Hey, Miss Willoughby.
Yeah.
I was just wondering how it's gonna work for math next year, as in how we do class. Because I was thinking I'm gonna take statistics.
Oh, I've already placed you in pre-calculus.
Yeah, you did,
But
college readiness math. What is that?
Am I in pre-calc?
Wait, what do you put in?
Like, wait, what?
Is that advanced decision making?
I don't know.
No, that class doesn't exist anymore.
Oh.
Why not? Okay, so, all right,
No, but I want to take.
fairly soon, we will all go to advisement, and you guys will get to see what I recommend. Generally, if you have really strong B's or A's in this course, we would recommend you for pre-calculus.
What if you don't work? What's a strong B?
The reason being, many of you plan to go to a 4-year university. It is in your best interest, if math is something that you can do, that you go into that 4-year university as prepared as you can do. So, and the case for many of you, pre-calculus is the best choice. Now, some of you do not like math, and you're not good at it, and I get that, because we're all good at different things. So, if pre-calculus is not a place that I thought you'd be extremely successful, I may have recommended something different. Okay? So, you are welcome to discuss my recommendation, and I'll tell you why I chose it. I spent about 5 hours researching I have 75 students in Algebra 2. So I looked at every single Algebra 1 grade, every single geometry grade. I looked up your milestone scores.
How do you do that?
And I looked at, I printed out what you made for me last year. In some of your cases, I looked at your average versus what you made on my finals. Okay? Because I had some underachievers that underachieved all semester and then killed it on the final, which lets me know that they have abilities beyond their effort. And so in those cases, those people will do average no matter where I put them. So I should put them at the higher level because they're going to hit that same mediocre bar no matter where I put them. So
That's not true.
yes, that's true. Okay, so you guys are welcome to discuss my choice, and if you disagree with it, that's fine. But I didn't just randomly go drop down box, drop down box, drop down box, pick. I actually did a good bit of research on every single one of you and tried to pick what I felt was in your best interest. Now, I don't know all of you. I don't know all of you extremely well. I know what I see in here 50 minutes a day. So please don't take offense, and please approach me if you have any questions. I'd love to talk to you about it. Okay. All right, so now that we're done with that, when we switch this one, it becomes natural log, folks, because it's basic. So it's the natural log of x equals the inverse of y. Okay, so check those, write those down.
I said I might take dance next year.
I think that's a great idea. Be a good outlet for you.
Doesn't matter if we put it as y negative 1 equals or.
No, it does not matter. Yeah, you can put that on either end. All right. So, let's take a look at the graphs. We're going to start with the graphs we did yesterday because logs are the inverse of that. So they'll just be switch the x and y. They'll be reflected over that y equals x line. And so that's how we're going to warm up to these log graphs. And I'm okay with 3 points instead of 5. So this was like yesterday. This is an exponential. This is the parent graph because there's absolutely no transformations to it. So when we do negative 1, 0, 1, 2 to the negative first is 1/2, 2 to the 0 is 1, and 2 to the first is 2. So when we go through here and graph this, it looks like this beautiful exponential curve here. And we have that little asymptote right here at y equals 0, which is the x-axis. All right, now, a log. So when we have, if I were to switch forms here, it's 2 to the y equals x. So if I pick values for x, this could be really tricky. But if I pick values for y, it's actually really easy. Because x is equal to 2 to the y. So with logs, you're always going to start with your y values because of the form of the function. It is much easier to start with your y values because this equation, y equals log base 2 of x, means 2 to the y equals x. So to find our x values, we take 2 and raise it to those y values. So 2 to the negative first is 1/2. 2 to the 0 is 1. 2 to the first is 2. It is. Because they're inverse functions, Do you guys see that those two just switch, the x and y? These two just switch, the x and y. These two switch, the x and y, because they are inverse functions. All right, so when we graph it, this one's going to be over a half, down 1, over 1, up and down 0, over 2, up 1. And when we look at this graph, it is actually reflected over the y equals x line. And let's see if I can, I'm usually terrible at drawing this in, but I'll give it a shot. Not half bad. It's a reflection over that line. Okay, now, this one, instead of having a horizontal asymptote, which you can see, there's no horizontal asymptote, there's actually a vertical asymptote right here. So log functions have vertical asymptotes. Yeah.
Yep, that way. That way, excuse me.
That's right. Okay, so let's do one more where we look at both the exponential and its inverse, the log function. And then we're just going to stick with logs. So this one, the exponential is y equals 3 to the x. So with exponential, x is the exponent. We do the negative 1, 0, 1 here. Because it's easy to find the y, which is 3 to the x. So 3 to the negative first, 1/3. 3 to the 0, 1. 3 to the first, 3. And that gives me my exponential function. Now, because this means the same thing as 3 to the y equals x, it is easier to start with negative 1, 0, and 1 here. And then 3 to the negative first is 1/3. 3 to the 0 is 1. 3 to the first is 3. And if we notice, when we look at inverse functions, they just switch the x and y. Okay, so if I went to graph these, it would look like this. 3, this one goes here, and it would have a horizontal asymptote.
Is there a mathematical way to find where the horizontal asymptote is?
The horizontal asymptote for an exponential will always be y equals 0 unless it's shifted up or down.
Okay.
The vertical asymptote is always x equals 0 unless it's been shifted right or left.
Sorry, what I meant was like the green line.
Oh, the green line
Yeah.
is always y equals x.
Okay.
The green line is just that line that it reflects over. Okay. Okay, so here we go. This is how we're going to do it. This is how you do it.
That's so funny.
Alright, so what we're going to do first is we're going to shift the asymptote, just like yesterday. But this time our asymptote is vertical. Okay, I take the blame for that. I started that one. Alright, this time the asymptote is vertical. So this asymptote gets shifted left and right. I'm about to lose. I feel like I'm losing. Okay.
You got it.
Alright, so
You got it.
we're gonna okay. Here we go. We're gonna shift the asymptote. An asymptote is such a weird word.
Have you seen that though?
No, I haven't.
You really need to.
Okay, it's gonna go right 1 unit, so it's gonna be right here. All right. So that horizontal shift left and right shifts the asymptote.
Wait, you shifted.
You shifted it left.
I did. I said right and then went left. Let's try again. Okay, there we go. For some reason I'm slightly distracted. Okay, and the shifting of the asymptote truly shifts the entire function. It just helps us to graph it in an easy way. And then what does the 3 do? It's going to move that starting point up 3. Which in effect moves the entire function up 3 units. That's what it does. It moves that entire function up 3 units. So I'm going to highlight this for us right here. This is where we're going to start from. Instead of starting from the origin, this is where we're going to start from. This shifted, transformed starting point. Now, my base is 2 this time. And I said we're going to do our y's because that's the easier way to do this. Because when I switch forms, x equals 2 to the y. The base is 2. The 2 to the y. The exponent is 1. So x equals 2 to the y. So this is 1/2. This is 1, and this is 2. So from this shifted point, we'll go over 1/2, down 1, over 1, up and down 0, over 2, up 1. Now we could do more points. There's another point right here. There's some more that are closer to the line over here. But that's good enough. 3 points and I'm happy. All right. We're going to talk about the domain and the range. I'm going to throw in zeros, but I'm actually not going to make you do that on your homework. I'm going to ask instead that you give me the equation for the asymptote, which is easier. Right here, the asymptote is x equals, it went right 1, so it's 1. X equals 1. So instead of doing the zeros in the homework, I'd like you to state the asymptotes. Okay, now, the range is the easier one. Because if we go back and think about the domain of every single exponential function, it was negative infinity to positive infinity. And when we switch the x's and y's, we switch the domain and the range. So the range of every logarithmic function is negative infinity to positive infinity. This domain, though, does have a restriction. It cannot hit 1 or go to the left of it. So it goes from 1 to infinity. It would be if we didn't shift it right or left, Emmy. True. Okay, now I told you I'd show you how to find the zeros on this one, and it's really easy. The zeros of the function are where the y value is 0. So we have this equation, 0 equals log base 2 of x minus 1 plus 3, and we would just solve that algebraically. We would move that 3 over, and this is something you definitely could do. I'm just not going to make you. And then my base is 2, so I would switch forms, and it would become 2 to the negative 3 equals x minus 1. Well, that's 1/8. And when we add 1 to both sides, 1, silly pin, we get 1 and 1/8 is our 0. Okay, so James, you have to do that. Okay. So to find the 0, you set the y value equal to 0 and solve.
So the asymptote is just the y, the x value?
Yeah, the asymptote is that equation for that vertical line, which is always x equals the x value on that line. Alright, we're going to do 3 together. We're going to do 11, 13, and I think it's 17. Because 17 is fun.
Why is it fun?
I like it. So it's fun for me.
difficult.
Fun for me.
11,
Alright.
13.
Yeah, 11 is natural log. Whoops!
Sweet.
Oh no. If it's natural log, what's the base, guys?
I don't know,
E.
you're way too excited about that.
So, I had cookie cake for breakfast. I'm just going to be excited today.
Ooh, cookie cake.
My second period brought in a cookie cake. It was a happy
Yay.
birthday to Miss Libby cookie
That's
cake.
so nice.
Yeah, it was awesome. Alright, so,
And kill you.
now, this is e raised to the y. Well, e is that crazy number. It's 2.71828 forever.
How many do
So-
you know? How many do you know?
I only know 5. 2.71828, and I'm happy. Alright, so this becomes 1 over e, which is 2.7. Good enough. It's kind of close to 3, isn't it? So it's kind of close to 1/3. And if we're sketching a simple little graph, that's kind of good enough. All right, e to the 0. Any number to the 0 is 1. And e to the first is 2.7. Good enough for sketching a graph. All right, now this horizontal shift shifts the function and the asymptote. So that's where we will begin. Where does the asymptote move to? -3. Let's do it. 1, 2, 3. Right here, folks. -3. Now, my starting position on this asymptote is up 2 units. Do you see that with the equation? So, I am starting from right here. This is my starting point. And I'll just highlight that so everybody sees. That's where we're going to start our basic moves for this function. I'm going to go over about 1/3, down 1. Over 1/3, down 1. Good enough. Over 1, up 0. Over 2.7, yeah, up 1. Sure. There we go, 2.71.
Oh, I messed up.
So from here, I went over 1, 2, and a sum, and up 1, 2.7.
Oh, okay.
Okay? And then I can sketch in my little curve.
Why can't they be easier numbers?
E's weird like that. But E is so helpful, it's crazy how many things E can do.
Wait, so how do you find 0 again?
No, you don't have to find the zeros back. Alright, so what you have to do is tell me the domain. Well, the domain got shifted back 3, so it goes from -3 to infinity. Every time it goes down forever and up forever, so the range is -infinity to +infinity. And I want you to give me the asymptote. The equation for the asymptote is x equals -3. Bingo. Okay, so now we're looking at 13 and 17. 13 because it has this reflection over the x-axis. And then 17 because it has a reflection over the y. So, this one, where does the asymptote shift to? Left 2. X equals -2. Okay, this is base 5 this time. So my x values are 5 to the y. So it would be 1/5, 1, 5.
But would it be negative?
Okay, we're about to talk about what that negative does. Okay, now let's look at this negative. A negative out in front of the function always changes the y's. So this actually becomes a +1 and this a -1. A negative in front changes your y's. So we go over 1/5 up 1. 1, 0. And then over 5 down 1. And there's my function.
Wait, did you count 5 from the last point? Or
I
5?
counted 5 from right here, my starting point. And I forgot to put my crosshairs there. So over 5, down 1. Because it wasn't shifted up or down any, so that starting point is still on the x-axis. So my domain is from back to -2 to infinity. My range is always -infinity to +infinity. My asymptote is x equals -2. All right, in the last 4 seconds, I have seen 4 students on their phones.
Take them up.
Wow.
Yeah, I need some food.
Alright,
Not me.
number 17 is fun, but it's different. This problem brings in a negative here. But not only does it cause that x's to change to the opposite, which reflects it over the y-axis, it also has a horizontal shift in here. And when there is anything here, a negative, a number, it must be factored out. And those of you that are going on to pre-calculus, this becomes a big deal when you're graphing trig functions. So, if there is a negative or a coefficient or anything here in front of our x, it must be factored out. And do you guys see how factoring it out makes this change and that change? Yeah. Alright, so this is where we look for that asymptote shift. That horizontal shift is still in here, but that negative had to be factored out first. So I'm still going back 2. Like I did on a problem just a minute ago.
And then down.
And down 3. So I've set up my starting point. Now let's figure out what I got here. I've got natural log, so it's base e. So this is e to the y equals my x. So 2 to the, 2.7 to the negative first is 1 over 2.7. E to the 0 is 1. E to the first is about 2.7. But we got this little negative hanging out right here.
That reflects.
And it's in front of the x. Instead of being out here in front of the function, it's inside with the x, which changes all my x's to the opposite. That's what causes the reflection over the y-axis. So instead of going right, I'm going left. Left a third, down 1. Left 1, up and down 0. Left 2.7, up 1. And so it looks like this. So my domain, because it goes forever left, goes negative infinity to that negative 2. My range never changes. And this asymptote is once again x equals negative 2. Alright, I think I gave you one more that had the negative with the x. So a negative with the x changes the x's to the opposite, which causes that reflection over the y-axis. Okay, the rest of the worksheet is yours. That's homework. Okay, and you have plenty of class time to actually finish it if you stay focused.
Relax, we got 5
We
minutes.
got a bus ride.
Oh, 6 minutes. Okay, you have at least enough time to get half of it done. These are fast.
Question.
Relax.